Ever wondered about the forces that hold our universe together? Welcome to our exploration of the first chapter of physics for Class 12, where we delve into the fascinating world of electric charges and fields. First things first, consider the concept of electric charge. It's a fundamental property of matter, which can either be positive, like in protons, or negative, as in electrons. Remember that like charges repel each other, and unlike charges attract. This is a fundamental rule of electromagnetism. Next, we move on to Coulomb's law. Named after the French physicist Charles-Augustin de Coulomb, this law describes the force between two charges. It states that the force between two charges is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. Afterward, we shift our attention to the electric field. Imagine a region around a charged particle where another charged particle experiences a force. That's an electric field for you. The strength of this field is directly proportional to the charge that produces it and inversely proportional to the square of the distance from the charge. Now, let's discuss the concept of electric field lines. They are imaginary lines that represent the direction and magnitude of the electric field. Remember, electric field lines originate from positive charges and terminate at negative charges. Next in line is the electric dipole. It's a pair of equal and opposite charges separated by a distance. The net charge of an electric dipole is zero, and it creates an electric field. Finally, we come to Gauss's law. This law, named after the German mathematician and physicist Carl Friedrich Gauss, relates the electric field at points on a closed surface to the net charge enclosed by that surface. That's a lot to take in, isn't it? Let's quickly recap. We started with the basic concept of electric charge, then moved on to Coulomb's law, which describes the force between two charges. We then discussed the electric field and its representation through electric field lines. After that, we examined the electric dipole and concluded with Gauss's law. Remember, physics isn't just about memorizing definitions and laws, it's about understanding how these concepts apply to the world around us. So as you study electric charges and fields, don't just learn the terms, understand them and see how they shape the universe we live in. Until next time, keep questioning, keep exploring, and most importantly, keep learning, because the world is full of wonders waiting to be discovered.